In this video, we can see about the generating set, span, basis and rank. So starting with the generating set, we can just consider a vector space V, which is equal to some set of vectors under the operations addition and multiplication. So if a vector is set of vector is named as A, which has x1 etc up to xk, which is a subset of V, then for any element that belongs to this vector space V can be expressed as a linear combination. That is, linear combination will be like a scalar value multiplied with this vectors, and taking the sum of those scalar multiple of those vectors lambda k xk will be called as the linear combination. Okay, so if there exists any linear combination for these vectors, then A will be called as the generating set of V. Generating set of V. Okay, so a generating set is like, if any vector, it can be expressed in the form of linear combination of these vectors, then A will be called as the generating set of V. And the set of all these linear combination, set of all linear combination of the vectors that is in A will be called as the span of A. Okay, so after performing this after forming this linear combination, it forms a set, and that set of linear combination based on the vector given in A will be treated as the span of A. That we can see it with the help of an example. So consider an example like V1 vectors, V1, V2, V3 vectors, which is having the values 2, 1, minus 1, vector 2, 0, 2, 2, and vector 3, minus 1, minus 1, minus 1. So these are the vectors. So you need to find the span of this A. Okay, or we can write like a span of V1, V2, etc. V3. Okay, so in order to find that, what you need to take? You need to take the linear combination. So linear combination will be like, based on the vectors it will be taking. So lambda 1 V1 vector plus lambda 2 V2 vector plus lambda 3 V3 vector, which is equal to V1 is 2, 1, 1 minus 1. So 2 lambda 1, then lambda 1 minus lambda 1 plus 0, 2 lambda 2 2 lambda 2 plus minus lambda 3 minus lambda 3 minus lambda 3. We will be getting the result like 2 lambda 1 minus lambda 3, then lambda 1 plus 2 lambda 2 minus lambda 3, then minus lambda 1 plus 2 lambda 2 minus lambda 3. So this is a linear combination formed, and this will be the span. Okay, So this is how you will be computing the span. Next is like you need to find the basis. Okay, so now you are you are aware of the vector spaces, span, and the linear dependence. So combining all this together, you will be able to find out the basis for the given vectors. So basis can be like defined as considering a vector space V, which is defined over some set of vectors under the operation plus and multiplication, addition and multiplication. Then we are considering a set of vectors named as A. So A will be a generating set of this V when we can say that it is a generating set of V if there exists a linear combination for the vectors given defined in this A, if there exists a linear combination, and set of all those linear combination formed from the vector will be called as the span. And generated set, if it is considered as a and the generated set of span will be a minimal set, that is the considered to be as the minimal set if there exists no smaller set. Okay, so if the formed combination or formed span, it is the minimal set. If there exists no smaller set, then that set will be forming the basis. Okay, so basis can be taken as some linearly independent vectors which will be acting as the building blocks, so that other vectors can be built on these vectors that is identified as the basis. Okay, so some vectors like v1, v2, etc., vk can be named as a basis. Those vectors, it will be belonging to V, and these will be termed as the basis if these vectors, they are linearly independent and the vectors, they span the vector space V. Okay, which means span of those vectors etc. vk will be equal to capital V. That is, they belong to the vector space V. Okay, so this is the condition you need to check for the vectors to be the basis. Okay, to identify the basis vectors from the given set of vectors, first you need to find the span, which means the linear combination will be found, and then we need to check for the linear independence and identify the columns that they are which consist of the pivot columns. If a pivot column exists, then those columns will be, or those will be representing some vector, and those vectors will be the will be forming the basis. Okay, so we will be able to understand with the help of an example. So we can just move to an example. So basis will be like a set of linearly independent vectors which will be used as a building block to make any other vector in the vector space. So we can consider an example like some set of simple example we can consider like set of vectors 1 0 0 0 1 0 0 0 1. So these are some vectors that is belonging to the vector space R3. Okay, so if the linear combination, you need to take the linear combination of these vectors. So if these vectors, it is having some right hand side. After performing the linear combination, it will be having some right hand side like a, b, c. Okay, so linear combination can be written as how? The lambda 1 into 1 0 0 plus lambda 2 0 1 0 plus lambda 3 0 0 1, which is equal to ABC, and these ABC, they are just constant values. Okay, some constant values. So from this you will be forming a matrix, isn't it? You are aware of that. You will be forming some matrix like this. Already the obtained matrix, it is in the form of row echelon form. So you will be getting some values like this. So from this you will be able to get the values for lambda variables as A, B, C. So here we got a solution, and these vectors, they are they span the vector space, that is R3. Okay, so it will be it will span the vector space R3. So a linear combination is existing for all the vectors that is given over here. So first linear combination condition is being satisfied, and next what you need to check for the linear independence. Okay, so for linear independence, what you will be doing, the linear combination, summation of that linear combination will be equal to 0. You will be taking like that. Sigma I is equal to 1 to k, lambda I x I will be equal to 0. That is the condition for linear combination in order to check for linear independence. So in this case, what happens? The matrix taken will be 1 0 0 0 1 0 0 0 1 will be equal to 0 0 0. So here lambda 1, lambda 2 and lambda 3 equal to 0. Okay, lambda 1, lambda 2, lambda 3 equal to 0. So linear independence case is there, and all the columns, they are having the pivot columns. So we can say that the vectors, if I am considering these vectors as x1, x1, x2 and x3, then we can say that these x1, x2, x3 vectors, they form the basis of of this vector space. Okay, so this is how you will be finding the basis of any vector. So this x1, x2, x3, it can be an element of capital A that we have learned in the theory part. So basis of this vector A will be taken. Okay. So we more examples you can try and see whether how you will be getting the basis. So for time being, I'm just checking with the next example for rank. Okay, now we have seen how to what is a generating set, how the span of that set will be generated, and how the basis of that set also is being generated. Next is like, in order to generate the rank of that vector, rank of the set of vectors, how you will be generating. So next concept is related to the rank. Okay, so rank is like you from the matrix that will be formed of the vectors, you need to find the linearly independent columns and rows. Okay, you need to find the linearly independent columns and rows, and that forms the rank of A. Okay, for example, we can just check rank of A is equal to 1 2 1 minus 2 minus 3 1 3 5 0. In order to find the rank of any matrix, you need to first perform the Gaussian elimination. Okay, so after performing some different row operations, you will be getting a matrix like 1 2 1 0 1 3 0 0 0. You can check it with your you can check with your solution that you are getting after performing the different operations. What you need to do, you need to make the diagonal elements as 1, and also the lower triangular matrix will be made as 0. So somehow you will be making use of the different row operations in order to get this form. And from the given matrix, you need to check the number of linearly independent rows and linearly independent columns. So linearly independent rows and columns, how you will be able to find? If the row, you need to take the count of the pivot columns and pivot rows to find the linearly independent rows and columns. So in this case, pivot row is 2 and pivot column also it is equal to 2. So we can say that the rank of the given matrix A will be equal to 2. That is the number of linearly independent rows and columns. So this rank of A, it will be represented like RK of A. Okay, this notation will be used to denote the rank of A, that is equal to 2. So you can just try it out with different examples to see whether you are able to understand the concept behind generating set, spanning, basis and rank.